slope and the equation of a line, slope, of course, is rise over run. That's what you've learned in the past. Rise over run. You've also thought about it as being y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Again, what are those referring to? Those are referring to your equations where you've got points, not equations really at this point. You got a point that's x sub 2, y sub 2, and you got a point that's x sub 1, y sub 1. So you take the corresponding points, your xy coordinates should be lined up on top of each other. Now, so we'll find the slope. And put in slope intercept form, which is y equals mx plus b. The line passing through (7, -2) and 3, -3. Or let's make it -3, 3. I hope you didn't write that down. Okay, -3, 3. So I want to know, first off, what's the slope, and then I want to put it in slope-intercept form. Now, there's also a form called point-slope form. This is slope-intercept form. Point-slope form we get from this equation right here. So let's think if we have m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And think about cross multiplying there. So I have y sub 2 minus y sub 1 equals m times x sub 2 minus x sub 1. Now, in point slope form, you're usually going to just have one point and one slope. So you can erase this and this. It's just y minus y sub 1 equals m times x minus x sub 1. In other words, this would be the x and y coordinates of the point that you're given. So we'll look at this one also. Point slope form and slope intercept form. So let's start off with this line passing through here. So first off, I want to find the slope. It does not matter which one I call point 1 and point 2. Let me just call this one point 2. So it would be 3 minus -2. Again, I'm finding my slope here. Over -3 minus 7. So 3 minus -2 is what? Well, minus a negative turns into positive. So 3 plus 2 is 5. And then -3 minus 10, minus 7 is minus 10. -10, yeah. So I get as my solution -1/2. So that's going to be my slope. That ended up be a pretty number. I was just making up 2 points. All right. So if I want to put this in slope-intercept form, the way I'm going to do it is I'm going to set this up in point-slope form. And after I get it in point-slope form, then I'm going to go to slope-intercept form. Now this is not the only way to do it, but this is just the way I'm going to do it. So I have y minus, again, my y sub 1 And I can use either one of the points, but let's continue to call this point 1. So it's y minus negative 2 equals negative 1/2, because that's my m, times x minus 7. All right, is there a question about that? All right. So this is point slope form. So I get y plus 2 equals, distributing in, negative 1/2 x plus 7/2. Again, if I do something, I'm going kind of fast so I can get this all in one video. So if I do something that y'all have a question about, please don't hesitate to ask me. Okay? So I need y by itself to put it in slope-intercept form. So I get y equals negative 1/2 x plus 7/2 minus 2. Now, in order to, this is not a situation where I'm going to multiply both sides by the least common multiple, or least common denominator. So this is y equals negative 1/2 x plus 7/2. Now, what do if I get a common denominator between those two, what would it be? If I'm getting a common denominator here between 7/2 and negative 2, what would that common denominator be?
2.
Yeah, how would I rewrite 2? 4 over 2?
Yeah. Or is negative 1?
Say that again?
Or is negative 1? Right. Never mind.
Are you good with that?
Yeah.
Okay, any question here? All right, so we end up, we can combine these two, so this becomes 3/2. So y equals negative 1/2 x plus 3/2. And that is that line written in slope-intercept form. Is there a question about that? Now, another way you could do it is you could get this form right here. And once you get it in this form right here, you could say, well, I know my y-intercept is when x is 0, so plug in 0 for x, and when you solve it out, you would get 3/2 as your answer, and then you would go back, that would be your b, so then you'd go back and plug in. So there are multiple ways to do this. I usually teach one way, and then half the students will say, well, I looked it up and saw to do it this way, and it was easier. That's great. I don't care which way you do it. Whatever way works best for you. I tend to find one way and stick with it, and this is typically the method I use. I usually go with point slope form and then solving it out for y, and that gets you the answer. But again, it's up to you. Now, there's one other form, it's called general form. In general form, is ax plus by equals c. You typically just see this form in problems where you're solving for systems of equations. Either elimination or Cramer's rule. But what it requires is that a, b, and c are integers, and a must be positive. All right, everybody good here? Okay. Charlie, you still copying this? Okay. I'll erase the one thing I didn't want to erase. I'm going to get someone to read me that equation out. So what was that? It was y equaled what?
1/2 x plus 3 halves.
Okay. Now, I need it in ax plus by equals c form. So the first thing I'm going to do is move this 1/2 x over here. So I have negative 1/2 x plus y equals 3/2. Now, it's in x, y, and c form, except the problem is these two numbers here are not integers. So what I need to do here is multiply every value through by the least common denominator. And that would be, in this case, what number? 2. But I also need to make this term here positive. So I'm going to multiply everything in here by negative 2. All right, so negative 2 times negative 1/2 x is what?
X.
Yeah, just x, right? 1x, negative 2 and negative 1/2 is positive 1. So 1x, then negative 2 and y,
Negative 2y.
and then negative 2 and 3/2.
Negative 3. 6.
But be careful, the 2's cancel out. So it'd just
Yes,
be
that's just negative 3.
negative 3, yeah. All right. So this is in the form of ax plus by equals c form. Only thing here is don't get this b value here confused with this b value here. This is a lowercase b. This represents this y-intercept. This b right here is not your y-intercept. It's just a coefficient value there. So that does it for this lesson.